Hi, today I'm going to present the data science tutorial for day 5. So here, mostly I'm going to cover, basically this is the start of application part for data science. So if you want to understand how the data science statisticians work, so most statisticians have been stating that data science is exactly what they have been doing for the last few decades. While this may be true to an extent, but we may not agree with them. Data science is completely different and separate from traditional statistical and mathematical approaches. Data science is different from statistics in different ways. For example, data scientists use programming languages to improve the efficiency of the analysis. If you are a statistician, you need to know the subject in its entirety. As a data scientist, you need to only to understand the basics of mathematics and statistics. Statisticians have very limited expertise about anything apart from statistics. They need to reach out the subject matter experts if they want any help or information about other subjects. They also need some help from experts to help them determine and understand the findings. This is the only way they can learn how they can move forward. On the other hand, a data scientist has enough information about different subjects that helps him or them to understand and analyze the findings with ease. A data scientist generates deep insights and uses his subject matter expertise to understand what the data is trying to tell them. So here you can see data science application sectors, that is banking, operations, genomics, insurance, and finance, human resources, supply chain, healthcare, and marketing. So if you summarize them, for example, it could be risk analytics, detection of fraudism, consumer analytics, user data management, and real-time analytics. In addition, there are some health sector applications which have not been summarized in this. But if you want to understand how which field is currently giving more jobs and more money if you are working as a data scientist, then here you can see insurance 107. So it means 100,000, 107,000 US dollar they are getting in annual as a salary or something. Automotive industry, advertising and PR, then further ahead, then aerospace engineering, real estate, e-commerce, finance, educational institutions, securities, contracts, and financial investment, computers, technology, and product manufacturing. So this is the data scientist salaries. And you can see where you are supposed to get more salary. But in a general, you can see this is much higher salary than any other field. So to get more earning, data science is one of the easiest way to get a really respectable salary. Now, proportion of industries using data science. Which industry is using more data science? On the top, it is software product, 14.69%, finance, then consulting, healthcare, education, internet, government, manufacturing, media, advertising, website services, telecommunication, consumer products, retail, aerospace, foundation and non-profit organizations, defense industry, automotive, and gaming. So this is how the percentages are distributed. The rest comes in others, which is 15.75%. That means almost 84.25% jobs or works are in these fields. So there is a good opportunity and
good occasion here also to learn where to apply and in which sector you need to look for the jobs in data science. Now, some of the real application, how you can apply. So here they are saying the following are some ways to use data science to improve the performance of business in specific sectors. For example, some architectural firms have begun to use machine learning algorithms to optimize the consumption of energy in modern design. Then marketing firms, then healthcare industries. A data journalist takes information from the website to identify any patterns and connections within in the data set. Then law enforcement agencies and organizations. So here I am showing you one of the application in health science. So this is wellness, clinical disease marker, then onset of disease, then detection of change in measured blood lights. So first detection, intervention, then return to wellness. So this is how, or disease, try to understand disease propagation or progression, then clinical diagnosis. So this is one of the finest example how you can think theoretically if you are working as a data scientist. Now, this is also the continuation part for data science application in health science. So this is discovery part, stage one. You need to look for the population of the patients, then deep phenotypes, then go for some computational analysis and blood biomarker identification. After that, you go for testing, that is stratification by blood biomarkers, testing cohort responders only, then treatment regimen plus deep phenotyping. So this is one of the finest example. And you can also see these analysis examples in detail with the original paper where it has been published. Now, communicate the insights captured through data. If you have data, if you are working on data science, you need to communicate, you need to understand and properly interpret the data by analyzing and implementing some machine learning algorithm. So here, first step is ask interesting question. For example, goal, the data, then what do you want to predict or estimate? Then get the data, samples, number of samples, the way in which the samples are being generated, then explore the data, plot patterns, identify the patterns, aberrations, identify the aberrations, then go for model the data, and finally communicate and visualize the results in different way of plotting. Then it comes leverage cloud-based solutions. If you're running your own business, then you can also think how to avoid your own investment. You can just think to utilize the services which are offered. For example, the cloud computing can be used for data storage, for processing, the processors. You just need to have one access computer to access the cloud. So power, computational power, processing applications, data models, data sources, analytic models, and then it is data storage or sharing. All these solutions you can get by using cloud computing services. Now, this is if you are working with R, which is very common R and Python. So I'm just going to show you the first step is exploratory analysis of data. So if you have the data, something in this format in Excel sheet or text file, you need to first import the file, that is file processing, file handling, and try to find if there is some discrepancies as typos, mistake, or some kind of errors which could be identified during file handling. So, for example, in which format they have been written, if it is with full stop or if it is with comma, what kind of the decimal points have been mentioned. And then you could go for some kind of basic analysis, for example, mean, median, average, minimum value, maximum value, many more things you can go. So you need to understand how the rows and columns are organized, how many columns are there, how many rows are there, and what is the type of data stored in each row and column. Then the step two comes when you clean your file properly to process it for analysis purpose. Then some of the results you could also plot as a histogram or box plot. So this is representing the histogram. So this is just to understand the frequency of certain values or certain things, how many times they are appearing. Something you can see here, 10,000. And then box plot is also another way of representation. So this is very useful since it shows you how skewed the data is. A box plot shows you the median quartiles in the data set. You can also use this to spot any outliers in the data. So use some code of R or Python or in whatever the coding you are interested. And this is how you can do in R. Now, the step three is the correction part. So here you need to identify the errors in the data set and determine methods and model you can use it to correct the errors in the code. You can also change the names of the data frames to differentiate between the accurate frames used. The syntax to change the name of the data frame, something could be identified by using the coding language which you are using. And data cleaning steps or correction steps could be include removing unwanted observation, missing data handling, structural error solving, outliers management. So removing unwanted observation, that means duplicate, redundant, or irrelevant values, deletion. Then missing data handling, fixing the issues of unknown missing values. Then structural error solving, fixing the problems with mislabeled classes and the names of features, same attributes with different names, etc. Then unwanted values which are not fitting in data sets, that is called outliers management. Now, if you want to understand the data science, then you can understand here how in exactly it could work when you start work on data science. So the data quality from data to data set, the full equation could be seen here. So you need to identify the errors, data conversion issues, data migration, system error, external data, then cleansing. Next is like to implement some model, to add model, to develop some of the model, then go for some kind of techniques, and finally try to achieve the objectives of your design project. And in the next class, I will be going further depth